Okay, welcome back, ladies and gentlemen, and we're looking at example 2. So I went ahead and I made my triangle. Now what I did was I looked ahead and I noticed that this angle was 105.2. So I made this a bigger angle than 90 so that my triangle might look a little bit half decent. So that's P. Now the side length, little p, is opposite the vertex, big P, so that's going to be 23.2 here. And R is going to be the side length opposite vertice R, so that's going to be 18.5. And notice what I did here. I did PQR, so PQR. Pardon me. So, looking at this triangle and seeing what I've got, it wants me to solve the triangle, which means I have to find all the interior angles and all three side lengths. It's not a right angle triangle, so I have no business using SOHCAHTOA, and I cannot use Pythagorean theorem. So I'm down to the sine law and the cosine law. I have a side and an angle. I have a side. Using the sine law, I can use that to get that other angle. So let's see how that'll set up. It'll be the sine of angle R over top of 18.5 equals the sine of 105.2 over top of 23.2. Now notice I didn't use a formula there. I used a relationship. This angle, sine, divided by that side length will equal the sine of this angle divided by its opposite side length. That's all I'm doing. So rearranging things here, sine of R is going to equal 18.5. The sine of 105.2 over top of 23.2. Now if it was me, I'd get that decimal. So 105.2 sine times 18.5 equals, divided by 23.2 equals, now I have this decimal, and I have to do the inverse. So angle R is actually equal to the inverse of this whole thing. And that is this decimal. So I don't care how you do it. And I don't really want to see this, by the way. You don't have to put this in. But I'm doing so that you see what's happening, and I come up with 50 degrees. So R is approximately equal to 50 degrees. So I know R now. Now I can come up with Q, because this is going to be 180 minus 105.2 minus 50. That's angle sum of a triangle theorem. So minus 50 minus 105.2, and I'm going to come up with 24.8. And angle sum of a triangle theorem. Okay, so I've got my three angles. I now need one more side length. I probably could use cosine law, but that seems like an awful lot of work. Let's use the sine law again. Why don't I show you how I came up with angle Q. We'll just put it over here. Angle Q will equal 180 minus 105.2 minus 50. And that gave you 24.8, just so I have it written down. Now you want your third side. Third side I'm going to call little q. I'm going to use the sine law again. So little q over the sine of 24.8. And I can use either of the other ones I want. But I'm going to use this one again because it's nice and it's handy. Over top of 23.2. Q is going to equal... Oop, there's definitely something wrong here. And look at, I can tell there's something wrong here because I've got Q over sine and then I've got sine on top here. So I haven't put the ratios in the, I've goofed them up. I've put the reciprocal of what I should have here. So that should be 23.2 and the bottom should be sine 105.2. So the sine should be on the bottom if the side lengths are on top. If the two sines are on the top, then both side lengths are on the bottom. So again, that was a goof. So what this is going to be is Q is going to equal sine of 24.8. Now that's just a number. Don't freak out about it. 23.2 over top of sine of 105.2. So using your calculator, 24.8 sine times 23.2 equals, divided by 105.2 sine equals, and I get approximately Q is equal to 10. And it looks like it's 10 centimeters. And so now what we have are, we have all the sides, 1, 2, 3. We have all the interior angles, And that triangle is solved. Okay, ladies and gentlemen, I'll stop here and come back for example 3.